So we can also use absolute values to find the distance between 2 points. This wouldn't be something you would need, right? Because if I asked you for part A on a number line, here's 0, would you agree that negative 3.7 would be there and negative 8.5 would be there? And if you wanted to find the distance between these, I'm pretty sure you could find it. Be no problem. Now, if we wanted to use the absolute value, what the absolute value lets you do is you don't have to worry about the order you put your numbers in. Okay? So, on my calculator, especially with working with negatives, when you want to find the distance between two things, you subtract. Like if I asked you what's the distance between 7 and 4, you'd be like, it's 3. In your head, you'd immediately go 7 minus 4, and you get 3. Okay? When you're dealing with negative numbers, your brain sometimes doesn't know which one to do first. Okay? Technically, when we're subtracting to find a distance, we would do the big one minus the small one. And if I draw the number line, I hope you can see that the big one is negative 3.7. So if I did negative 3.7 minus negative 1.8, negative 8.5, I'll get the right answer. Calculator. Oh, that's so negative 3.7 subtract bracket negative 8.5, 4.8. So I would tell this is 4.8. But if we wanted to use absolute values, it wouldn't matter if we screwed up the order. I want to find the distance between 8.5 and 3.7. Well, what happens if I screwed up on the order and put the wrong one first? It won't matter because, first of all, I simplify inside, I would get negative 4.8. And then the absolute value says, well, make it positive. In the end, you're finding the distance. We get 4.8, whether you do it in the right order or the wrong order. So it's kind of nice that way because you can just put the two numbers in and subtract. Wouldn't matter which one's bigger, which one's smaller. Part B. Here's my number line. Here's 0. One number is 4 2/3. The other number, negative 5 3/5. Most likely you wouldn't screw up in your subtracting here. You would probably realize the positive one is bigger than the negative one. But if you're concerned, you can put the absolute value 4 2/3 minus negative 5 3/5. Subtracting the negative is the same as adding. But now, how do we add these fractions? Okay, there's a couple of ways. Going back to grade 9, you learned a bunch of different techniques with fractions. They come up over and over again. Probably, once you get to higher levels, the most common thing that people do is change them to mixed fraction. From a mixed fraction to a proper. So 4 times 3 is 12. This is 14 over 3. Minus a negative is plus, and 25 plus 3 is 28 over 5. This is also nice for your calculator. Okay, so once I have it, it's in proper fraction. If this was calculator, I could go to my calculator now and do 14 divided by 3 plus 28 divided by 5. I get a decimal. If you have a graphing calculator, what's really cool is under math, the very first button lets you change that back to a fraction, and then your teacher thinks you did all the math correctly. Yes. So, now, I'm going to cheat. So I'm cheating with my calculator. Was it 154 over 15? If I didn't cheat with my calculator, I would need a common denominator, right? Common denominator with 3 and 5 is 15. So I multiply this by 5, this by 3, add my tops. And get 154 over 15. I think your textbook at the bottom, change this to 10 and 4/15. Okay? That's probably the most common way to add fractions. I don't mind, for mental math purposes, 4 and 2/3 means 4 and 2/3 plus 5 and 3/5. If you don't like big numbers, this is actually quite nice. What's 4 plus 5? It's going to be 9 plus, common denominator here is now a lot smaller numbers, right? I'm going to have 2/3 is 10/15. 3/5 is 9/15. That's going to be 9 plus 19/15, which is another 1 and 4/15. Mental math there might be a little bit easier. So again, reviewing some mental math strategies that you may have learned in the past, or maybe didn't quite see, or maybe you saw, but you weren't ready for them in grade 9 to really understand them. I hope that makes sense as a technique now that you're in grade 11. Okay, so questions for this one?